You know, there are some ideas in science fiction that just stick with you. And for me, the Stargate is right at the top of that list. So today, we're going to do it. We're going to dial the chevrons, step through the event horizon, and see just how much real science is hiding behind that shimmering blue portal. I mean, think about the premise. In the world of Stargate, you have this incredible device that lets teams like SG-1 step from Earth to a planet light years away in a single stride. It is, without a doubt, the ultimate shortcut. But here's the really wild part. As crazy as that sounds, the actual scientific concepts that inspired it, I'm talking about tunnels through space-time and particles that are linked across the entire cosmos, are somehow even weirder than the story itself. So yeah, that's the big question we're tackling today. Where does the Hollywood magic end, and where does the mind-bending actual science begin? Let's find out. Okay, so before we dive into the deep end of theoretical physics, let's get on the same page. In the story, what is the Stargate and how is it supposed to work? The whole thing kicks off right here. Back in 1928, archaeologists in Egypt uncover this massive, ancient ring. It's made of a metal nobody's ever seen before, and it's covered in these strange glyphs. For decades, it's just a mystery, a silent, colossal artifact waiting for someone to figure it out. And that someone is, of course, Dr. Daniel Jackson. He's the one who finally cracks the code. He realizes this isn't just some ancient relic, it's a piece of technology. It is, as he translates it, a door to heaven, a Stargate. So the premise is just so cool. A team dials an address using those glyphs, the ring lights up, the chevrons lock, and this incredible shimmering blue event horizon appears. Travelers step through, their matter gets converted to energy, and it's beamed through what they call a stable wormhole, where they get put back together on a whole other planet, instantly. All right, so that phrase, stable wormhole, that's our bridge from fiction to fact. It's the key scientific idea that gets this whole train rolling. So let's talk about it. In real-world theoretical physics, a wormhole is exactly what it sounds like. It's a tunnel. It's a hypothetical shortcut that would punch right through the very fabric of space-time itself, connecting two incredibly distant points in the universe. The classic analogy is still the best one. Imagine space-time is a big sheet of paper. To get from one side to the other, you have to travel all the way across the surface. That's the long way. But what if you could just fold the paper in half and poke a pencil straight through? That little tunnel is the wormhole. You see, it's not about traveling faster than light. It's about making the distance you have to travel ridiculously shorter. So, the Stargate relies on a stable, traversable wormhole. Sounds great, but when we check in with what actual physics has to say, well, we run into a few complications. Now, this idea has been around for over a century. It first showed up as just a weird possibility in Einstein's equations. Then Einstein himself, along with Nathan Rosen, formalized the idea of these bridges. It wasn't until the 50s that physicist John Wheeler gave it that awesome name, wormhole. But for a long, long time, it was just a mathematical curiosity. Until Kip Thorne came along and asked the billion-dollar question. Yeah, but could you actually travel through one? And this is where the science fiction dream smacks right into the wall of reality. First off, those original Einstein-Rosen bridges, they're incredibly unstable. They'd basically collapse faster than a beam of light could even get through. To prop one open, our theories say you'd need something called exotic matter. Think of it as stuff with anti-gravity. It pushes space-time apart instead of pulling it together. The problem? We have never, ever observed anything like it. And to top it all off, even if wormholes do exist naturally, they'd likely be on a tiny subatomic scale. Not exactly something you can walk through. But there's another piece of this puzzle. That idea of an instant connection between two stargates, well, that echoes another very real and frankly even weirder scientific concept, quantum entanglement. Entanglement is just one of those things about quantum mechanics that breaks your brain a little. It's where you can have two particles become fundamentally linked, part of the same system. And from that moment on, they act as one, no matter how far apart they get, whether it's across a room or across a galaxy. This concept was so bizarre, so totally counterintuitive, that Albert Einstein himself just couldn't accept it. He famously called it, and this is a great phrase, spooky action at a distance. He just hated the idea that measuring a particle right here could instantly influence another one way over there. So here's how it works. You've got two entangled particles. If you measure one and find its spin is up, you instantly know the other's spin is down. That correlation is instantaneous. But, and you got to hear this is the most important part. You can't use this to send a message. Why? Because you can't control the outcome of your measurement. It's always random. So you can't force your particle to be up to send a 1 to your friend. It's an instant connection, but it's not communication. Okay, so let's bring it all back home. We've looked at the fiction, we've looked at the physics. How does the Stargate actually stack up against reality? Well, when you lay it out like this, it's pretty clear. The show gives us a big, stable wormhole. Physics says they're likely hypothetical, unstable, and microscopic. Stargate activation is a simple dial home address. A real one would need this exotic matter we've never found. And the instant link? For Stargate, it's beaming people across the galaxy. For real-world entanglement, it's just an instant correlation. No messages, and definitely no people moving faster than light. And honestly, this is the magic of what great science fiction does. It takes these truly mind-bending ideas from the very edge of human understanding, like wormholes and entanglement, and it just runs with them. It asks that amazing question, what if? It imagines a universe where we've already solved all the impossible problems, and in doing that, it inspires us to wonder about the limits of our own universe. So while we might not be dialing up another planet anytime soon, the real science that inspired the Stargate is still pushing the boundaries of what we know. And it leaves us with a really exciting question, doesn't it? What other impossible sci-fi ideas are maybe just one big discovery away from becoming a little bit closer to science fact?